Okay, here we go. We have created one entire setup. One setup to machine away, looking at the part from this side here. Okay. Now what we've got to do though is create a new setup that's going to be looking at this part from the opposite side, over here. So what we want to do first here, instead of doing model orientation, select Z-axis plane and X-axis. This seems to throw some people off. Don't try and overthink it too much. Right now, Z-axis is going off in the wrong direction here. We actually want the Z-axis to be aligned where the Y currently is, but going the other direction up positively this way. So the way that I do that, now clicked on Z-axis, nothing selected. I clicked on that. I could either click on this axis here if you can see it, or you could even click on, say, an edge or something like that. Okay, and then X-axis now, instead of being that edge, that was incorrect. I want that edge to be our X-axis, but they're going the opposite direction from what I want to see here right now. It's going down. I want Z to be going up. I'm going to flip the Z-axis direction. I'm going to flip the X-axis direction. That looks good. Now this is going to get a little bit touchier though in terms of where I want my actual zero origin to be right now. I could select a stock origin point right there, and we're going to tweak our stock here in a moment. But I actually want now for my origin, I really actually want to be aligned with, say, the actual model face that's underneath here, that model face there, and this model face back here. It's going to take a little bit of doing to get that set up. So I don't want box point. I would actually want a model box point in this case right here. And that is more appropriate for right now. We're going to have to do a little bit out at the machine to tweak to get this here, but that's not going to be too difficult to do. But yes, I want my origin now to be aligned to a face that I've already machined, and ultimately isn't dependent upon the stock up here, but potentially more actually likely from position relative to there, up to there that I've already established. But anyway, for now, that's what I'm going to claim my stock origin to be. All right. Now, with that set, we got to come into our stock here. So, not a relative size box anymore. I'm going to do a fixed size box again. Instead of being width of 3 inches in X, 2, that's fine. But instead of the Z height here, I'm actually going to use a value of 0.225. How I got this value was subtracting from 1 inch, which was the original overall height of the stock. I'm subtracting the part finish height, which is 0.750, 3/4 of an inch, and the 25 thousandths of an inch that we removed in that first operation. So we removed 0.025 from there. So if you subtract 0.75 and 0.025 from 1 inch, you end up with that value. It's in red right now. Z height is less than the height of the selected model. Yeah, correct. I know I'm not going to be machining this full model. Now, instead of center now, I can do offset from Z top. And instead of negative there, I'm going to do 0.225 again. Look at that. It is now actually representing what was the stock left over from the previous operation. And is going to allow me to then more appropriately set up and remove just that element here from that. Cool? With our origin now is not in relationship to the stock top up here. And here we go. All right, clicking OK. So it says Z height less than the height. Do you want to ignore this warning? Yes, I do. I know what I'm doing. I'm semi-professional. Here we go. All right, we have now got our other setup here. Okay. From here, it's going to be simply coming back to a facing pass. Okay. We don't want to use a chamfer mill for this. Select. Guess what? If you're back here with your library, you can click on this. We still want our 3-inch face mill. Okay. Now with that, we're going to try something else that we didn't do in the last step to show a slight difference. So instead of the bottom height, so the bottom height is going to go to the model top. Take all that away. From top height is going to be from the stock top, which is cool, which we had there. And now passes, step over that way, pass direction 0 degrees, that's fine. Stock offset, don't want to change anything there, so we could go beyond a bit. Step over 2.85, sure. Multiple depths. In this case, we might want to take some multiple depths, because taking that big of a finishing or a step pass, I don't think our face mill can handle that. But I believe could handle a 50,000th step down. Okay. And then a finishing step, I suppose, of finishing feed rate. That's nice. We can alter that if we want then. Finishing step down. Let's make that a 0.25 for no better reason to show you that we can. Okay. We do not want to leave any stock on this one. All right. Linking parameters here. There is linking parameters coming down, extend before retract, it's beyond the stock before retracting. Yeah, so this might be good. On the previous operation that we did, the face only came down here, came to about here, and once it knew that the tool cleared off the part, it actually came up instead of coming all the way across. That sometimes leaves some inconsistent surface look that you may not like. Sure, we could do that on this one to see what happens. The lead in entry, lead out. There's actually another one here in passes that I'm trying to find. At that pass extension, this kind of does the same thing here, so that we could go, like I said, beyond the boundary, step over. It's use chip thinning. This option here, while we're machining aluminum right now, this may be less of a big deal. But say if we were machining titanium or some stainless steel or high nickel alloy, this here will save some wear and tear on the face mill, because it will actually take, instead of coming in just vertically straight in across here, it will actually take a round path and ease the cutter into the cut. It's a bit more technical, but for right now we'll click that for use chip thinning for right now, just to see what that does and looks like. Okay, so there we go. Now here's what that chip thinning before on that first operation that we did with the face mill, it actually just comes straight in here. Now the difference with this is that it's actually taking this blue pass, curving in here to take that pass up at the top part. But then the following depths, it's not doing that. But anyway, we can simulate this. It's already down in the cut, so it's coming in, stepping down, and voila, we have now machined away that stock, and we're left here with this part. Now what we can do to really finish this part out nicely potentially, and this is also then the important one, we're coming to a second operation here. This is the reason why I'm selecting this face, and this face is the work origin. We could come back around and use now a chamfer mill to just lightly graze and clean up and deburr this outer edge of this part here. The way we're going to do this now, 2D contour. Instead of using the face mill, that would be ungood. We're going to come back and use our chamfer mill. Okay. We then will select as the geometry this outermost contour. It's good to see we've got that little red arrow. That's a good indicator we got good stuff going on here. Now, this is again where a contour, we don't actually need some model feature in order to actually remove material away. Now what we're going to do is heights here. Instead of selected contours, we're going to come down, let's see here, passes. Excuse me, that was then off of passes, not off of heights. You got to come here to passes. It knows that we're going to be chamfering. And our chamfer width here, let's set that to less than 20. We're going to want to make it less than that big one we had before. It's really just going to be a light deburring thing. So we're going to do 0, 1, 0, 10,000ths chamfer. And again, chip tip offset, let's take this down, I don't know, 0.025. That means that the chamfer mill is actually going to come, it's going to do the calculations for you to make sure that the tip of the chamfer mill is slightly below that edge, because if we try and use exactly the right little tip of that chamfer mill, it potentially will gouge into this part and not look very good. So that's an important thing. 10,000ths chamfer width, 25,000ths chamfer tip offset. We don't want to leave any stock, no other smoothing, anything else. And the last other thing here is making sure that we have our compensation type selected as wear. Okay, and here we go. We could even repeat the finishing pass or do a finishing pass, but let's click OK on that. It's now calculating. It's a little tough to see exactly what happened here, but it is plotting a trajectory or a path around the outside there. The other thing that I do probably want to do, I'm going to re-edit this. So instead of passes here, we're going to do finish overlap of, again, 100,000ths of an inch, just to make sure that we get a bit smoother finish around. Okay. So again, it started its path around this point here, and it's now finishing right there, and it's going off and away. Okay, now if we simulate this whole thing, play. Through, remove that material away. Now we're using our chamfer mill to come in here. Now in the simulation, it's not doing the best job of actually showing what material was removed away here. We would actually have to drop the stock level down a little bit, which is also going to be a little bit touchy. So note to Fusion 360 developers, if you can figure out how to come up and generate a stock from previous operation function that's more accurate to this whole setup and then include that, that would be an awesome feature. But they're probably working on it at some point, have probably higher priorities at this point. But anyway, but yeah, with that then we actually have what will end up being looking more appropriately like a completely finished out box like that. Cool. And then we'll get to engrave on this, but that'll be another day.